Good evening. Good evening and welcome to the third cohort of Blockchain Foundation program. Myself, Nikhil B. Chandran, R&D engineer at Kerala Blockchain Academy. Today we will be discussing about the course and how to go about finishing the course and the introduction to blockchain. So before we begin, about Kerala Blockchain Academy, KBA is an initiative of Government of Kerala under the Indian Institute of Information Technology and Management for offering blockchain training in multiple domains. So we offer training in developer programs for Ethereum developer programs, Hyperledger developer programs, and also startup programs. We have also a development team which is working on cutting edge blockchain projects related to the government and other industries. So the KBA aims to become a powerhouse in teaching and a development garage, and it also has a research group and innovation clubs. Now, today, let us begin by introducing the Blockchain Foundation program. As you know, this is a free course and you all will have free online self-paced learning content access. So free online self-paced means you will have 1 month free access to all the course content, and it will cover all the blockchain fundamentals. So for 1 month, you will have a free learning self-paced learning experience, and you can access all the course content for free. There are total 4 quizzes for evaluation, and you can have 2 attempts per quiz. So each quiz you can have 2 attempts, and minimum 60% mark is required for each quiz to pass that quiz. So for example, if you go for the week 1 quiz, then you have to pass week 1 quiz with minimum 60% mark in 2 attempts. And you can have a maximum of 2 attempts, so you can pass with minimum 60% marks. Then only you will get access to quiz 2. Similarly, you can finish quiz 2 with 60% marks to get access to quiz 3. And if you finish quiz 3 with 60% mark, you will get access to quiz 4. And if you finally, when you finish quiz 4, you will get the Blockchain Foundation program certification. Now, you can communicate with us by posting queries on the discussion board. So on the course page, there is a discussion tab, and you can post whichever doubts you have on that discussion board. Okay, and the cohort will end on October 31st at 3 p.m. IST. So that is the end date and time for this cohort, the October cohort. So those who have enrolled in September, they will be getting access in October. So you will get access in October, and you will be able to complete the quizzes till October 31st at 3 p.m. when we will be removing the access. Finally, when you complete all the 4 quizzes with minimum 60% mark, you will be eligible for a digital certificate that will be issued on the blockchain. So we are using EOS blockchain, and you will be getting that digital certificate on that blockchain, and you can just verify the validity of that certificate with the QR code. So this is about the BFP course. Now moving on, the course content overview. So what all are the contents of the course that you are going to learn? So in week 1, you will have the introduction to blockchain. So in that, we will be covering what is a blockchain, working of blockchain, history, and evolution of blockchain. So these are the contents of the first section in week 1. Then you have the section for blockchain story, like what is the history of currency, what is the need for decentralization, and so on. So these are the basics of blockchain that are covered in week 1, where you will be learning about what a blockchain is, what is a node, what is a network, a blockchain network, what is the working of a blockchain, how a transaction is committed onto the blockchain, the history and the evolution of blockchain, the history of currency, how it evolved from paper currency to digital currency to cryptocurrencies, the need for decentralization, why do we need to decentralize the current ecosystems, and these all will be covered in week 1. In week 2, you will have access to the introduction to blockchain content. So all the weeks you can have parallel access. All the weeks are available for you from week 1 itself. So in week 2 content, you will be covering about the introduction to Bitcoin, what is Bitcoin, working of Bitcoin, and the applications of Bitcoin. So basically what a Bitcoin is and the basics of Bitcoin. Then in the second part of week 2, you will be covering the consensus mechanism, like the proof of work that is used in Bitcoin based protocol or the mining based consensus mechanism, the proof of stake consensus, the practical Byzantine fault tolerance used in permission blockchain. So proof of stake is more used in Ethereum kind of systems, and practical Byzantine fault tolerant kind of consensus mechanisms are used in mostly permissioned blockchains. So in week 2, you'll be covering Bitcoin and the consensus mechanisms. So that is about week 1 and week 2 content. Now moving on to week 3, you will be covering the details of introduction to Ethereum, or what is an Ethereum, how did it came about, what is Ethereum world computer, what is an EVM, maybe the basics, just the basics of what Ethereum is, the concept of a smart contract, the concept of decentralized applications, and that will cover the basics of two public blockchain like Ethereum, or programmable, introduce you to the concept of programmable blockchains. Then in the second part of week 3, you will be covering about introduction to Hyperledger, the distributed ledgers, Hyperledger Fabric, Hyperledger projects and tools, and all the different other kinds of Hyperledger projects like Sawtooth, just the basic information about the other projects like Sawtooth, Iroha, Burrow, etc. So this is also a basic introduction to both permissionless blockchains like public blockchains like Ethereum and permissioned distributed ledgers like Hyperledger in week 3. Finally, the final week, you will be having the content regarding blockchain use cases, like how blockchain is useful in banking, supply chain, healthcare, government, and so on. So these are some of the areas, or a subset of the areas in which blockchains can find potential use cases. And we'll be discussing also about the future with blockchain. What can we do with blockchain, the current challenges that blockchain faces, and the current trends in blockchain. So this is the content overview of the 4-week course that you will be covering. And at the end of each week, you will be having an evaluation in the form of a quiz, which you have to complete with minimum 60% mark to be eligible for the next week. And all the weeks you complete with 60% mark, you will get the certification. Now, today we will be just introducing the concept of blockchain. So this is not intended to be a instructor session, just to get you acquainted with the concept of the blockchain. We will be covering some basic stuff of blockchain in this further in the next sections. So what is meant by centralized versus decentralized networks? So we can take a simple example, like on the left you can see a classroom example where there is a teacher and there are students in a classroom. So the teacher is reading, or she is lecturing the students, and the students are listening to the teacher, like what I am doing right now. You are all listening to me and I am speaking. So similarly, the teacher is lecturing to the students and the students are all listening there. So who is controlling that classroom? It is being controlled by the teacher. Whoever is controlling that classroom, it is being controlled by a single teacher. Now on the right hand picture, you can see that there is no teacher. Maybe the teacher was absent on that day and the students are having a fun time. So you can see that in this example, in this right example, the students are not being controlled by anyone. Everyone is doing whatever they wish. There is no form of a central authority that is controlling the students, right? The teacher is absent there. So similar to this example of this teacher example, in a classroom example, we can consider centralized systems and decentralized systems. So centralized system means they are being controlled by a central entity like a server or a centralized authority. Maybe it is being maintained in a group of servers, or it is being controlled by a centralized authority. But in decentralized systems, there is no notion of a centralized server or a single entity that is controlling the system. It is working on the principle of a collective decision making of the network. So in the classroom example, if the students, they all decide to study and they all agree and they form a consensus, then that will form a decentralized system which is working, a classroom which is working without a teacher. The students are reading from the book and studying by themselves. So that is a kind of a system which is decentralized, and the rules are enforced by the network or the collective decision making of the participants in that network. So in this example, we can consider the students as each individual student as nodes in a network, and the network itself as the classroom, and the different nodes will communicate with each other through messages, and they will come to an agreement on what to do with their time, right? So this is an example of a classroom analogy between centralized and decentralized systems. So I hope you have an understanding of how a centralized decentralized system is very much different from a centralized system. Now moving on to the concept of a blockchain. So unlike storing in a single book or a database, the blockchain is distributed and decentralized across many parties over the internet. Like the classroom example, instead of having a single teacher teaching the entire class, the entire blockchain, it is being distributed and decentralized across many parties over the internet. So it is an immutable global book for trusted transactions. That means once you commit something onto the blockchain, it is not supposed to be modified, or it cannot be modified, right? So that is the concept of immutable global book for trusted transactions. So why the name blockchain came about? So as you can see in this example, there are different blocks that are having a linkage with other blocks in the network. So this block is connected to the previous block by a linkage. So the third block is connected to the second block by a linkage, and so on. So the last block is connected to the second last block by a linkage. So these blocks are actually groups of transactions in a blockchain network. A block is a group of transactions. So a collected group of transactions, they are collected together and they form a block. So a block has a header and a body part. So the header part will have the metadata part, and the body part will have the transaction. So basically the transactions are grouped into a block, and the blocks are all linked to the previous block by a cryptographic mechanism. So these mechanisms are cryptographically linked. These blocks are linked to the previous block by a cryptographic linkages. So in that way, there is a block of transactions and a cryptographic linkages known as a chain. So this block of transactions and cryptographic chain forms the blockchain. So this data, this ledger is being kept by all the nodes in the network in public blockchains like Bitcoin and Ethereum, EOS, or so and so on. All these public blockchain will keep the entire copy of the all the blocks in the network, from the first block to the latest block. That all the nodes in the network, all the full nodes in the network will keep the entire copy of the blockchain. So this is why it is known as a blockchain, because it is grouping a group of transactions into a block, and all the blocks are linked to the previous block by a cryptographic linkages known as previous hash. So it is known as a hashing mechanism, So hashing means a cryptographic mechanism in which it uses a mathematical function to convert a particular data to a particular particular data to a hash value, a particular fixed value known as a hash value. Usually it is a hexadecimal value that is being converted. So the input data is converted to a fixed length hexadecimal value known as a hash value. So these linkages means the previous hash will contain the hash of this block, the previous hash of this will be stored in the next block, and previous hash of this will be stored in the next block, and so on. So I mean, not the previous hash, the hash of this block will be stored in the next block, and so on. So the previous hash will link this current block's previous hash will link to the previous block's hash. So that is how the blocks form a chain of cryptographic linkages known as the hash. So previous hash. So that is how blockchains are formed. Now just breaking this down into an analogy with pages and books and people who are keeping a copy of these books. So in that way, let us suppose there are some pages of a book, individual pages of a book. Let us analyze each and every individual pages of a book. Then let us form a book from all the pages, and finally let us distribute or keep a copy of all the of these books to different people that are distributed across the network. So there are different pages that are grouped together to form a book, and these books are then kept by different people who are maybe they are geographically separated, they are not in a single location. So they are all geographically separated people, and they have a copy of the book. Now in blockchain terms, a page in this book will represent a transaction. So let us represent a page as each individual page in this book as a transaction. For our convenience, we are representing each individual page as a transaction. So these individual pages will form a book or a block of transactions. So maybe we will for some point of time, say 10 minutes time, we are collecting for 10 minutes we are collecting all the pages that we have and forming one book. So that will form one block, right? So for 10 minutes we are collecting all the pages that we can collect, maximum number of pages that we can collect, and that is forming one block. Now what we are doing is we are now then sending this block of transaction to different people who can be attributed to different node in the network. So different nodes in the network will get the different blocks, right? And after 10 minutes one block is complete. Then we will collect pages for another 10 minutes, and after 20 minutes another book will be formed. So from 11th minute to 20th minute we will get so many pages. We collect all those pages together to form book 2, and book 2 will be sent to each and every node in the network. So this is how a blockchain works. So there are individual transactions that are grouped to blocks, and these blocks are all sent to different nodes in the network, and these nodes are all containing the copy of all the public, at least a public blockchain, a full node, or each node will contain the entire copy from the first block to the latest block. So these nodes will be keeping the entire copy of the blockchain. So I know I'm trying to explain the very basics, so if you already know all this, so please bear with me, because this course is intended for the the most basic students, those who have no exposure to blockchain. So for those people I am explaining about the basic concepts of blockchain. Now how can we define this chain? Okay, now we define the blockchain as a decentralized, distributed and immutable ledger technology. Now this can be a real-time open ledger for recording any type of transactions like data with no single owner. And when did this blockchain concept come about? It came about in 2008 by a white paper known as Bitcoin, a peer-to-peer ledger technology. So here this white paper that introduced by an unknown entity known as Satoshi Nakamoto. We are not sure who that Satoshi is, and we can define a blockchain as a cryptographically linked group of transactions that are stored in a decentralized manner in different nodes in the decentralized network. So there is a mechanism that is controlling the chain that is known as a consensus mechanism that will enforce the rules of the chain, and there are different nodes or computers or systems in the network that will be running a protocol known as the blockchain protocol, which will define the network rules and the consensus rules, and according to that software this blockchain will work. So most of the public blockchains, they are running they are not having any access restrictions. Anyone can join the network. It is immutable. Once you commit a transaction onto the blockchain through as a block of transactions, then that committed block of transactions is immutable. You cannot modify the previous block contents, and you can only change the state of that particular block of transactions. So the concept here is that if you have suppose you are storing a values such as x is equal to 10 in block number 1. In the first block you are storing a value x is equal to 10 onto the blockchain. So that in that block in a transaction you send that value to the blockchain. So that value will be broadcasted to all the nodes in the network, and all the nodes will have the copy of that value, like x is equal to 10. Now some time has passed, and now the current running latest block is block number 10. Now you want to change the value of x from 10 to 100. Now you cannot go back to block number 1 and change that value there. That is known as a immutability property. Once it is stored, it's a fixed record of transaction. You cannot change that record. Now what you can do is you can change the state of that record, or that particular record or state of that particular variable x can be changed from 10 to 100. On the latest block you just send a new transaction saying modify x value from 10 to 100. So in the 11th block, now latest value of x will be updated as 100. So what is a state? You are listening to my speech, and I am talking. So my state is talking and your state is listening, and our combined state is me talking and you listening. So the state of a blockchain is state of all the components of that blockchain. What is the current state of that blockchain? What values are stored in that current scenario, etc. So that is how we change the state of a blockchain. So these are some of the basics doubts that the previous cohorts students have asked. So you might be also having that same doubts. That is why I explained that concept. Now there are also other concepts like programmable blockchains. So the basic blockchain that came about in 2008, known as the Bitcoin blockchain, it was intended to be a financial blockchain. So it is intended to be a currency that will replace the current financial ecosystem. So it was not intended to be a programmable blockchain. So the ideal of Bitcoin is as a cryptocurrency or as a tradable as a form of money exchange. It is not intended to be anything else. As per the developers, they are not intending it to be anything else rather than revolutionizing the current financial system by becoming an alternative to the fiat currencies like dollar and rupee. So the fiat currencies are the currencies that are in existence and that are acceptable by the governments. Like in India, the fiat currency is rupee. dollar is the fiat currency for US and so on. So then came the concept of programmable blockchains later. After the introduction of Bitcoin came the concept of programmable blockchains, which we will discuss in the later sections. So defining a chain, there are public blockchains like Ethereum, Bitcoin, etc. These are anyone can access the network. And there are also distributed ledgers like Hyperledger is a permissioned distributed ledger. So a distributed ledger means there is no concept of decentralization in that distributed ledger, because there it might be the network might be having some form of centralization. It might be under the control of a consortium of banks, or it might be under the control of a consortium or a group of companies and so on in a supply chain. So these are known as distributed ledger technologies. These technologies, they are trying to gain the advantage of concepts that are defined in public blockchains and apply it to a enterprise scenario. And there are various innovations that are coming up in that scenario as well. So these are known as distributed ledger technologies, like Hyperledger projects are one example. So that is all regarding the blockchain, the chain part. Now going on to the a basic history of the blockchain, how what happened or how it came about. So the history came in 2008. A document was published online called Bitcoin, a peer-to-peer electronic cash system, by an unknown identity or a group of people known as Satoshi Nakamoto. So this paper introduced the concept of Bitcoin, and later in 2009 it was launched. The main network, the Bitcoin main network, was launched, and the first transaction took place between Hal Finney and Satoshi Nakamoto in January 2009, and later slowly it grew in popularity as an alternative to the traditional or the fiat currencies as a digital gold concept, because it has a fixed supply. Bitcoin has a fixed supply of 21 million Bitcoin. It is having that digital gold kind of aspect. So people started noticing the underlying technology behind Bitcoin and the potential of Bitcoin. And by 2010, the first real world transaction of buying 2 pizzas was done. And the interesting aspect is that its value is a huge value. If you convert 10,000 BTC, then it is around 10,000 into around $44,000. So maybe you can just imagine how much money it was worth at that time. But at that time, it was worth very less, because at the initial stages, one Bitcoin was $0.001 and so on. So it was not worth that much at that time. But later its value increased, and currently the value of 10,000 Bitcoin might be a very huge value. So by between 2010 and 2019 until today, a lot of development took place, and this is a fairly new technology. Like 2009 to 2021, it is just 12 years old. So it is not a very mature technology. It is under constant development, and this technology, in 2015 there was the revolution of programmable blockchain introduced by Ethereum and by Vitalik and co-founders of Ethereum. They introduced the concept of programmable blockchains, and then a series of initial coin offerings and whatnot, so many other things came about. By 2019, it was very much in popular. Bitcoin came about in popularity, as well as Ethereum and other public blockchains. They were very much popular, and you can imagine the electricity consumption by the mining process of Bitcoin is very much comparable to that of a company like a Czech Republic, which is a country of around 10.6 million people. So there is a consensus mechanism that is used in Bitcoin to come into an agreement. Like I said, in the case of a classroom scenario, you have to come to an agreement to do some rules in that network. In a classroom, all the students should agree to do some rules, because it is not having a central authority telling it what to do next. The network itself will come to an agreement based on some protocol rules, based on some code that's enforced. So that rule is enforced by a mechanism known as proof of work consensus mechanism, and that consensus mechanism requires a puzzle to be solved, and that puzzle solving requires very expensive hardware equipment, and that hardware equipment consumes so much power that it is comparable to the nowadays it is comparable to the consumption of a medium sized company or country. So that is the power of blockchain, or how it exploded, how the technology grew over the past 12-13 years. Now coming to the introduction to Bitcoin, a little bit about the introduction to Bitcoin. The Bitcoin protocol, Bitcoin with the capital B, it is a protocol for decentralized peer-to-peer network. So this protocol creates the consensus without needing a central authority to provide the trust. So this decentralized protocol is represented by Bitcoin B, and this Bitcoin with the small b, we can represent it as a currency or the tradable token that is issued as a reward after the mining or the proof of work mining process as the reward. And the Bitcoin blockchain is the public ledger where the network records the transactions are written. So when Satoshi introduced the concept of Bitcoin, the underlying ledger part was noticed by so many people, and that technology was adopted, and from that came about the revolution of blockchain as we see it now. So many blockchains came about later that are adopting or that are based on the Bitcoin blockchain. So always when we talk about blockchain, we cannot exclude Bitcoin, but Bitcoin is not just the blockchain. Bitcoin is just one of the blockchain or the first blockchain. It led to the creation of more than thousands of other kinds of blockchain later over the past 5-10 years, right? So the Bitcoin with the capital B is the decentralized protocol or the peer-to-peer network. The Bitcoin with the small b is the currency, and the decentralized ledger is known as a Bitcoin blockchain, right? So that is just to clear the doubts regarding what is a Bitcoin with a capital B, what's a Bitcoin with a small b, and what is a Bitcoin blockchain. Now moving on to the difference between a dollar and a Bitcoin. So let us compare dollar with Bitcoin. So dollar is accepted by the government or backed by a centralized authority. It is controlled by banks and governments. But Bitcoin doesn't have a centralized authority. In terms of dollar, it has a paper currency aspect as well. So transaction may or may not be recorded on a ledger. But in Bitcoin, there is no paper transactions done. All the transactions are recorded on a decentralized ledger, and it is publicly available. In case of dollar, it is a legal tender. In case of Bitcoin, it is not a legal tender yet. The governments have not accepted it. So if the government accepts it as a legal tender, then only it will become a legal tender, which is having a minute possibility under the current scenarios. There is no supply cap in case of dollar. So that means the government can keep on printing more and more currency. So during the pandemic times, the US Federal Reserve, who is controlling the dollar in circulation, they have printed more than trillions, many trillions of dollars were printed due to the crisis, due to the economic crisis. But that cannot be done in a cryptocurrency, in a fixed supply cryptocurrency like Bitcoin, because it has a fixed supply cap. Maximum number of Bitcoins will always remain the same as 21 million, and that is enforced by code or law. So you cannot have more than 21 million Bitcoin in existence. So that is the difference between fiat currency like dollar and Bitcoin. We are comparing specific dollar to Bitcoin. In case of other blockchains like Ethereum doesn't have a supply cap. So Ethereum is not like a digital gold. It doesn't have a supply cap. You can create more and more Ethereum. But Bitcoin is a digital gold kind of thing. It has a fixed supply cap, right? So these are the difference between a fiat currency like dollar or rupee and a cryptocurrency like Bitcoin and Ethereum. Okay. I hope you understood the difference. Now moving on to the working of blockchain. So how does a blockchain work? How is a blockchain working? when we send a transaction. So usually how you can interact with the blockchain, you can interact in the form of directly you can communicate through nodes, running a node on your computer, a blockchain node on your computer, but that is very difficult. So most of the cases for a user level perspective, mostly you will be communicating through wallets. So wallets will communicate with the actual blockchain node for you. So in case, let us assume a transaction. So let us assume Bob is sending a transaction to Alice. So someone will initiate a transaction. Suppose Bob is initiating a transaction, send 100 rupees to Alice. So 100 rupees in cryptocurrency. So send 100 rupees in Bitcoin to Alice. So that transaction is then sent across the network, and the wallet will send that transaction to a node, and that particular node which receives that transaction will broadcast it to the rest of the nodes in the network. So the other nodes in the network will verify that transaction, whether it is valid or not, and it will check the syntax and semantic, only the syntax at the first case, whether it is sent by a valid sender, whether the signature of Bob is valid, whether the recipient address is correct, and so on. So the network nodes will verify that transaction, whether it's a valid transaction. In the next step, it will collect a lot of such transactions, the nodes in the network. So these are, let us say these are the different nodes in the network. So we have 1, 2, 3, 4, 5 nodes, and these nodes will collect different transactions over a period of time. Say 10-minute time in Bitcoin, it will collect maybe 3,000, 4,000 transactions, and they add that transaction to a block. So these are known as a candidate block. So each node will create a block of transactions. They will create a new block of transactions with the currently received transactions. They will collect it from a place known as the memory pool. So the memory pool is a place where all the transactions are kept before they are added onto the blockchain, or they are confirmed onto the blockchain. So in case of Bitcoin blockchain, the memory pool is kept by the miner nodes, and the miner nodes will then take all the transaction based on the transaction fees. So if you give more fees, you have more chance of getting confirmed onto the blockchain network. Finally, one block is selected out of all the different nodes by a consensus mechanism. So the consensus mechanism used in Bitcoin blockchain is known as proof of work consensus mechanism. So proof of work means it uses a cryptographic puzzle to solve for a puzzle, and that puzzle is a lottery mechanism. Like you can maybe you will get it right, that puzzle right, maybe you will not. So the chance of you solving that puzzle faster increases if you have more powerful computers. So that chance is directly proportional to the hashing rate or the power of that computer. So more hashing power means you will have more chance of solving the puzzle. So it is a mathematical puzzle solving that is done by all the mining nodes in the network. They will solve for that puzzle in case of Bitcoin, and that is the leader election done. Now one of the nodes, mining nodes, will win that particular puzzle. It will solve that puzzle first. Whoever solves that puzzle first will be elected the leader, and that leader node's block of transactions is the selected block. So one block is selected from the leader node, and that leader node will have the privilege of proposing the next block. So the selected block is then sent across the network with saying, okay, the leader node will then send the selected block to the other nodes in the network saying, okay, I have solved this puzzle, and please send this node to the next rest of the across the network, and please accept this as a valid block of transactions. Next, the nodes, all the independent nodes will independently verify the block of transactions whether it is valid or not. And once it is verified that it's a valid leader node, it is actually solving the puzzle in the fastest time, and it is actually solving it, and it is a valid blocks. Each and every transactions are valid inside that block. Then the nodes will add the block to the blockchain. So if the transaction that is sent by Bob to Alice is in that particular block that is selected, then that node will be when that node is added to the blockchain, that particular transaction will be confirmed, and finally the transaction is complete, and Alice will receive that 100 rupees in Bitcoin from Bob. So this is how the blockchain works. I explained in terms of Bitcoin blockchain. It will change slightly in different blockchain, like in Ethereum, it is using the same proof of work consensus mechanism, but it is changing to a proof of stake consensus mechanism. In Hyperledger, there is no concept of mining. It is using other mechanisms like Raft, PBFT, Paxos, etc. So that is how the working of blockchain is done. This is for basically the flow for public blockchains. It will differ in different blockchains, and it will differ with permission mechanism might have a slightly different working of blockchain. Finally, coming to the application of blockchain in daily life, one example. This is a permissioned blockchain example, like Hyperledger based example. IBM was approached by Walmart, which is a supermarket chain, to trace the origin of goods from the source to the end consumer. So traditionally, IBM, when Walmart was checking for the source of goods that is existing in their store. In their store, they have vegetables, and they wanted to know from which farmer this particular mango came, or which pork, from which farmer this, or which farm this particular pork came. It required around 1 week time or 6.5 days to trace from which farm that particular mango came. That was the delay in tracing. Like it was a lot time consuming process to track the source of the produce. So the goal of this Walmart project that was given to IBM. So IBM used Hyperledger, a variant of Hyperledger Fabric known as IBM blockchain, and they tracked the origin of the goods using a distributed ledger. So how it is done, all the different suppliers, there might be hundreds of participants in that supply chain. All the participants were onboarded onto a common distributed ledger, and each and every participants will have permissioned access, selective access to the content that is required to be seen by that particular participant in that network. So in that way, this particular distributed ledger was able to reduce the tracing time. So maybe in the final product, in the mango packet, it can have a QR code, or in the box of mangoes, it can have a QR code, and you can just scan the QR code, and it will show for all the history of, it will trace the entire history of that good from the farmer or the origin to the end consumer, which all participants at what time, from which farm it came, and the entire thing. So how can it impact? Suppose this particular batch has to be recalled. That particular batch of mangoes has to be recalled because it is poor quality. Then Walmart can now identify which all batches are from that particular batch. All the mangoes can be identified and it can be recalled. So that is known as selective quarantine. Then reduced transaction cost can be achieved because now this much entire process is now onboarded. Now there can be reduced reduction in the complaints, the customer complaints can be reduced, and so on. So that is the one simple application of blockchain in daily life. So that is all that I have to explain to you. So I explained what all contents you have in your course, the 4-week content. I gave an introduction to blockchain, and I gave all the rules and regulations regarding the course. I hope you have understood the introduction to blockchain. At the end of this course, we will meet once again, and we will have one more interactive session. So I hope you all will attempt all the quizzes and get certified. All the best, and goodbye for now.